Yeah. He came back right before I left. So are we good on sound? Outstanding. So anyway, I met your father, really cool guy. So my name is David Jones. I'm a cybersecurity scientist at VMI. I work in the Cyber Defense Laboratory. We specialize in reverse engineering and IoT exploitation. We're also reimagining how we teach cybersecurity to everyone. And the reason why is everyone needs to be taught cybersecurity. So what is cybersecurity? Cybersecurity in a nutshell is the protection of physical assets. That's critical infrastructure. Like you guys hear the Colonial Pipeline attack? All right, what happened there was somebody had taken a virtual machine and archived it, and the passwords that was used for the administrative login for that was leaked into the dark web. So they came into this archived virtual machine and then they penetrated their network. But more importantly, they used a vulnerability that CISA, which is the Cyber and Information Security Agency, had sent mitigation out almost a year in advance. And that's one of the issues that we run into. You'll hear a lot in boardrooms about compliance. We need to comply. There's like HIPAA compliance for privacy security. We deal with FERPA at universities, person identifiable or information, but the problem is compliance is a trailing indicator. Our government is designed to move slow. Our laws are designed to move slow. So by the time our government gets around to creating a bill, getting it signed into law, and then defining regulations to get out to everybody else, it's already too late. So we have to re-educate everybody from the toddler level to the boardroom. How many people, when you go out to a restaurant, you see a parent or an older sibling hand a mobile device to a toddler? That's a common occurrence. What we do not do is we do not teach that toddler about the outside world. What we did was we gave them a window to the outside world. And if you ever see a toddler, as soon as you turn your eyes away, they're already into your mobile device, looking at the web, bringing up applications, maybe downloading some things that are compromising your devices. How many here have antivirus on their phones? Raise your hand if you like being compromised. Who here believes they're not compromised? All right, so if you don't run your antivirus, right, anti-malware, keep your stuff patched, and use secure Wi-Fi, there's a high probability your device is compromised. Even if you do all of that, there's a probability your device is compromised. Who here has taught or taken a programming class anywhere? Okay. How many semesters?
4, 5.
Okay. How many semesters?
2.
How many semesters? Okay. Did you? How many semesters? Okay. Who here has learned application security? Now, is it because you learned it in IT? All right. So you all are already 2 to 4 to 5 semesters into your programming journey. You're already starting to learn all the bad habits that you don't want. Has anybody ever stored a password in a text file or clear text or put it in code? Anyone? Has anyone ever accessed the database or used the web service for a login? Anyone? And where do you get those credentials? Do you use a key store? Do you use a key manager? Do you use a certificate? So they're teaching computer science and programming the way I learned it back in the 80s. We haven't changed. What in the world has changed since then? Well, now we have this new term, cybersecurity, right? And that started late 2000s. But before that, we still had hackers. We had hackers way back in the 70s. So we have people hacking, now we have ransomware gangs, right? So we're not teaching our students secure programming. And this is how easy that is. There's a program it's called So Now You Know, SNYK. It works for Java, Python, C, and C++, and C#. It's just an add-in that you throw into your individual development environment, and you push a button. And what it tells you is, do you have any known vulnerabilities? What's your code quality? And that is very easy. By just showing your students in your computer science and programming classes just how to download that one add-in and push that one button, all of a sudden you're starting to implement application security. Has anybody taken a networking class at all?
Way long ago.
All right. Did you work on switches, routers?
Just the basics about them, yeah.
Okay. Did you guys learn a concept called the black hole VLAN?
No.
Okay. Outstanding. So a black hole VLAN, all it is just a virtual local area network. You have your switch, and that's all you need is a switch. You have your general virtual network, and then you have this black hole VLAN, so the ports that are on your switch that aren't in use at the time, it goes into that VLAN. Now, why do you do that? Well, switches, and there have been a lot of advancements. The fact is, you could plug a network cable into a switch and repeatedly do FTP requests against that port. It's called port knocking. It'll activate that port. It's turned off, it'll activate it. So, whatever VLAN that port is on, you now have access within the switch. And if you don't have any router rules that's outside of that, you can actually traverse from the switch across your network just by somebody having physical access. And that leads me into my next segue, physical access. Who here knew that Zach still leads security around here, right? No? What? All right, so, well, then we better talk to security guy because I'm parked down here in the 10-minute zone. So, security, right? SVU has its own security force. Most people don't realize that they are the first line of defense. They are cybersecurity. They're physical asset protection. Locks on doors, cybersecurity. Of course, magnetic locks are cybersecurity. Now, why do we need cybersecurity? Everything we do as a modern society requires that we need to protect our access or our assets. So imagine, all of a sudden, farmers in the Midwest and the Southwest, all of a sudden their crops started drying up. What happened was an adversary just came in to their programmable logic controllers that control the water, and all they did was make it look like it was being watered every day, and it was only being watered every third day. Now your crops are starting to wither. What happens about our livestock? They're on automated feeding schedules. They're on automated watering schedules. What happens if the programs that control these schedules are changed, where they're not being fed, they're not being watered? A lot of our farm equipment works on GPS and it's automated. People don't drive anymore. What happens if you completely lock these tractors down with a ransomware attack to where they can't go harvest the food in the fields? Within about a week, our big cities would start to show the effects because you couldn't get food from the field to our cities. At the same time, an adversary comes in and changes the lye content. Lye is used to purify water. This actually happened down in Florida. They changed the lye content up to, I believe, 10,000 times the normal. And what that does is corrode pipes, but it also makes this water very caustic and poisonous. So you have sensors all along your waterways, and it tells you what's going in there. Is there any impurities? Well, an adversary comes in and changes this level of lye, and all of a sudden, you no longer have potable water for a huge metropolis. 3 days, the body can go without water. What happens if you start having a water shortage? Transportation. Everything we do runs off of transportation. Airways, railways, trucks, boats. What happens if a ransomware attack happens and it shuts down our air traffic control system? Passengers aren't going anywhere. You know, that's a problem. However, everything we transport by air isn't going anywhere. Space. Cyberspace is now in space. And what cyberspace is, it's all the computers, the links, networks, communications that it takes to form our internet. We have it in space because we have satellites, but more importantly, it's interplanetary. We have rovers on Mars. We have satellites circling Mars. We have a Chinese rover on Mars, so now we have cyber conflict on another planet. But our cyberspace isn't just our solar system. It's actually interplanetary. We have Voyager 1 and 2, which left our solar systems, I think, in the early 2000s. They were launched in the mid-70s. They are now interstellar, and they are still beaming back unencrypted information. You could tap into those endpoints, and you can hack JPL, and you could hack NASA. Now, will something like Independence Day happen where some aliens come, they just jack into these things and take us over? I don't know. But it's a consideration. Back then, security wasn't even considered. It's still not considered. I still have conversations with people that have worked for the Department of Defense on their networks, and they still don't patch their routers and their switches. And they don't believe in patching routers and switches. And these are industry veterans. So we need to re-educate our workforce. We need to re-educate our professors. We need to re-educate our students. We need to re-educate everybody, and at the same time. And it's a huge, huge effort. Does anybody have any questions so far? Okay. So, what is the field of cybersecurity? Well, it ranges. There's policy, right? Policy is very important. It's how leadership in an organization defines how you as an individual are going to perform your tasks, how you can use their equipment, what you can access, what you can't access. It helps you perform. There's risk management. Risk management tries to define how likely is an attack going to occur, and more importantly, what is it going to cost us? Is it highly privileged data? Is it a system that if it went down, our organization would stop today? Or is it just like a public server serving readily available public content that really doesn't have an effect? Or is it this? Right? If this went down, I don't know, nobody might care. John Sargent, he's here, right? Yeah, he would care, right? But what about the adversary that hides in here? They know you don't care. Has anybody ever heard of these things getting patched? Yeah, they hide there. That's a vulnerable spot. Printers, a vulnerable spot. So we have to re-educate our HVAC people. We have to re-educate our vocational trainees. But there's more, right? So we have white hat hackers and red hat hackers and black hat hackers, right? The black hats are the truly bad guys. The white hats are the individuals that try and harden systems. The red hats are the guys that attack the black hats. Most people that learn cybersecurity will go out and start watching videos, fantastic. They'll start learning how to do penetration testing and vulnerability analysis, equally fantastic, but they stop there. What happens if you do all that and you don't find any vulnerabilities? Does that mean vulnerabilities don't exist?
You just didn't find them.
Yeah. Zero-day exploits. They're there all the time. Why? Because we have people programming that have never learned application security. We have engineers that don't design security at the start. I'm involved in an autonomous driving vehicle project over at VMI. I just assigned some of my cyber captains to that project. They are going to help get this thing on the road. It's using Arduino. and it's using Raspberry Pi. It's using sensors. Excuse me. It's using what they call a CAN bus as a messaging. But you see the cyber captains even slipping back into the old thought process. Well, we need to get this thing running first, and then we'll talk about security. Well, I can tell you, I have a lot of gray hair, and I can tell you one thing. Security administration are always addressed last. And when it comes to a budget, and when it comes down to project time crunch, what are the last things to go on a project?
Security.
Yeah. It's everything that hasn't been done yet, right? So if you're crunched down to time or it's moved up, everything goes. So it is continuous effort. So I have a question. What is your interest in cybersecurity?
Mostly just curiosity.
Okay. Any specific part?
I'm kind of trying to figure out what the different parts are to see kind of where I want to kind of focus my attention.
Okay. And go ahead and state your name, because I only know 3 people here.
I'm James, and I guess kind of the same thing where I just have a general interest in it, but I don't know a whole lot about it. And I'm joining the IT team, so I should probably know about it.
Outstanding. Oh, outstanding. Congratulations.
I work in the IT office.
Yeah.
It is a work relevant curiosity and also just information I should probably already know.
Okay.
But also working with the development team,
So,
helping them out with that.
security development, and then also I'm doing cybersecurity for the school now. So it's also my job to know.
Outstanding.
Work in IT, just does media production and other things.
Perfect.
Sweet.
He's here for this.
I'm the wild card.
Nice. And how about you, Dr. Swift?
I've got big shoes to fill in IT, so I have to learn. Within like a couple weeks, I need to know as much as you know. So.
And you have your doctorate in what? Media and rhetoric? Okay. Who knew that that was cybersecurity? Yeah. Rhetoric, misinformation. So there are Russian intelligence agencies just geared towards misinformation. Why? It's cheap, it's easy. Who here has heard of open source intelligence? Oh, this is where it gets really cool. It's called OSINT for short. Basically, you can use a tool called Maltego or Creepy. And by using that tool, I can tell everything about you all. By using Creepy, I can establish a behavior of life pattern. I can say when you go, wherever you went, I'll know about it, how often you went, who you went with, even as you're there if you're on social media. And I know how many times. I can start establishing an intelligence dossier on you.
Quick question about that. Does that also include location information on like mobile devices?
Absolutely.
Location on your phone's on?
Every time you take a picture, geolocation is recorded in that picture image. And then you upload it, right? Because you say, hey, check me out, me and the buds, click, upload. Posting information. Everything you post is available to someone like me. And y'all haven't even given me access to your network. But due to the fact that social media sites sell their information to other sites and they collect it, eventually everything gets out in the world. Open source intelligence, by the way, is a huge, huge career field. If you go to a site called intelligencecareers.com, that is every open intelligence job in the United States. That is every 3-letter agency and the armed forces. And what you're going to see is a lot of open source intelligence. Why is open source intelligence so powerful? Because it's all legal. You can learn how to do reconnaissance like a hacker. You can create sock puppets, or basically fake social media profiles. And then you join networks. And by the way, they even have capture the flag events, where you form a team and you compete against teams across the world, but what you're doing is finding missing people. You're finding lost loved ones. You're helping to find the next lead. Maybe that could bring somebody home. That's fantastic. But open source intelligence, it's used in the sports industry. You want to know what your competitor's doing. More importantly, you want to know what your prospects are. You're going to get their game film. You're going to get all their information and their packets. But by using open source intelligence, you can actually tell what they actually do. There's also image intelligence. That is where you just take a picture and you break down the picture. You see all the metadata of the picture, but you also tell what's going on in the picture. And by the way, there's a thing called steganography, where they actually hide data inside a picture. We ran a capture the flag where you actually had to pull a zip file out of a picture. You had to decrypt the zip file, and then you found your information. That was pretty cool. Cryptology, cryptography and cryptanalysis. Cryptography, you encipher, decipher, which is you take one letter and change it to something else. That's encipher. And decipher, you change it back. There's encryption, decryption. That's where you take entire phrases, sentences, and change it to something else. That is a huge field, huge field. Reverse engineering. If you like to learn how things work, there's software reverse engineering and hardware reverse engineering. And you go and find exploits. Cybersecurity scientists, research, huge field. Private cybersecurity researchers and government researchers can make anywhere from $150,000 to $250,000 a year. And that's just with a bachelor's degree. So if you have calculus 1 and 2, discrete math, do you guys still teach theory?
Mm-hmm.
Outstanding, right?
There's multiple theory classes.
Oh, you're looking here.
Is there automata?
AI?
No, it's automata. Artificial intelligence, that's also huge in cybersecurity, right? With that, you now have the basis to go on and get your advanced degree in cyber defense. And there's a lot of universities out there with cyber defense. Unknown to SVU administration and leadership, we were very close into being able to give SVU a guide on creating an MOU. That's a multi-organizational unit. We were working with Loyola Marymount University, that's over there by Washington, D.C. They have a doctorate in cybersecurity, applied cybersecurity. And what we're going to do is, at VMI, we were going to offer 400 level classes that are 400/500 level courses. So you have 12 to 15 units of your master's or doctorate knocked out of the way before you even graduate. That's a huge cost savings. Here in Virginia, you only need 18 units of advanced or graduate study to actually teach at a university. So what does that mean? They can spin up a cybersecurity program. They can create an MOU with Marymount and other universities around here, pay for your certificate degree, come back with 18 units, and you can start having additional students teaching cybersecurity. Is there any questions so far? Is there anything that I haven't touched on that you are interested in hearing about? Anything you've heard anywhere? Outstanding. All right, so the DoD, Armed Forces. I am constantly having internships come across my desk. Very, very lucrative. These internships will pay for your top secret clearance and your polygraph or counterintelligence. That is a $500,000 expense. They pay for it, you graduate, you have a job. But more importantly, as long as you keep that security clearance, you have a job for life. That is a golden ticket, and you can go anywhere. Now, there are internships open to Centers of Academic Excellence, and they are offered, it's called an SFS scholarship. So long as you're accredited as a CAE, either in cyber defense, CD, Cyber Defense Education, CDE, or Cyber Research, R. Your students can have a full ride for 3 years. Sophomore, junior, senior, full ride. But more importantly, you go off to internships. In high school, you can get these internships and they'll pay you on a GS 2, 3, or 4. What that equates to is about $23,000 to $25,000 annualized over a 2-month period. However, for high school students, it's GS 5, 6, and 7. Now you're talking about 30,000s. When you graduate, all you have to do to get that scholarship is spend your time at a federal, state, or local government agency. There are huge amounts of scholarships everywhere. These internships are available every year, not only through the ROTC, but through the civilian side. Right now, I have internships available for MAR4 Cyber. That's Marine Force Cyber. This is the first one I've seen across. They actually tell you, we're going to teach you offensive and defensive cyber. That's the first one. Usually they stay away from those words, offensive cyber. But they'll teach you, and they'll pay you. 40 hours a week, 3 months in the summer. You come back, they're going to run your credit check, or they're going to run your background. And by the time you graduate, you're going to have a top secret with counterintelligence and have a job. We have it for Army Cyber Command, US Cyber Command, Air Force Cyber Command. The only thing we don't have is the 10th Fleet for Navy, because of VMI, they don't commission straight into their cybersecurity. You can't commission there. However, we have a lot of defense contractors looking for people. It is a very, very, very lucrative field. And if you think that you have to be STEM to get a job, no. There are tons of jobs for linguists out at intelligencecareers.com. If you know Arabic, if you know Chinese, if you know Spanish, you can get a job. There's a bunch of other languages out there. Open source intelligence. Maybe you like collecting intelligence. They'll teach you how to collect it. Maybe you don't know anything about cybersecurity. Well, the good thing about SVU students, they're a lot like VMI students. You don't do what normal, or what, I shouldn't say normal, what most college students do. You have fraternities, but what you don't have is keg parties, right? While it's still possible for an SVU student to get a DUI, I think it's highly unlikely you're going to get a DUI. So SVU students are already geared to clear this top secret process. And all you need to do is apply. That's outstanding. Private industry, they use what's called competitive intelligence. They want to know what their peers are doing, you know, how they're doing it, what pitfalls they had, how to avoid that, but more importantly, what are they doing well? Let's mimic that. So you have intelligence, you have reverse engineering, you have exploitation, you have penetration testing. That's both hardware and software. You have application security. If you know cybersecurity, Kubernetes, and Python, you can get a job, a 6-figure job, pretty much right out of college. In about 2 to 3 years, you could be making $250,000 working anywhere in the world you want. And this is called DevSecOps, Developer Security Operations. That's where you're bringing NetOps together with developers and you're putting security right in the front. More importantly, when you become a senior DevSecOps person, you could be making up to $500,000 because they can't find people. They can't find people for this field. And why can't they find people for this field? Well, we don't teach cybersecurity in universities. If we do teach cybersecurity, it's usually just policy and risk management. It's easier to find people that can teach policy and risk management even in high schools. That's the first thing they implement. It's low cost, low barrier to entry, but you start on your path. It's the STEM, non-STEM, that is very difficult, like psychology, behavior analysis, cognitive theory. Without behavior analysis, what good is machine learning? Machine learning learns what you do. By the way, another big field. AI uses cognitive theory, neural nets. Without artificial intelligence, we have 26.6 billion IoT devices currently. In about 3 years, we're going to have over 50 billion. Within a couple years past that, it's going to be 100 billion. And how many people are on this planet? Roughly about 8.6 billion. How many of those people can actually watch what's going on? Not much. So you have AI and machine learning help you defend, but also to attack. However, now that you bring AI and machine learning in, what happens if you corrupt the data that's used to train the machine? It's not effectively trained. What happens if you're able to hack into a neural net and you're able to change the AI? Make it do what you want, make it say what you want. And these are all things that have to be taught, right? Coming back to education. CyberSmart. It's for high school students, put on every year by VMI. So I taught them how to social engineer. I taught them how to create sock puppets and avatars. I taught them how to target me in an open source intelligence operation. And the reason why I taught them offensive cyber, which is red team, because I wanted to open their minds to blue team, which is defensive cyber. It allowed me to ask some very simple questions. And going back to open source intelligence, when you were creating your social media posts and your pictures, did you ever intend for me to get it? Now, they came back, they said, hey, we posted it. And it was a conscientious effort, right? They posted it. However, I just asked them, what was your intent? Was it to go to your family, your friends, maybe your acquaintances? Was it ever to go to someone like me to use it how I want to use it? And the light bulb turned on. They're like, wow, if we knew this before we started using social media, we would not post half the things we do, and the things we do, we would post a different way. And the light bulb went on. And then I addressed some homeschools, because we teach everybody. And the parents, their jaw just dropped. They had no idea that just by giving somebody a TikTok or a Snapchat access to this, that this information can start being collected on their children, and that is being collected on their children. This is what's really scary. TikTok, a lot of audio, a lot of video. Does everybody know what deep fakes are? Okay. It's artificial intelligence that creates this video and this voice of someone. Now, imagine all this video now that's out there on TikTok and all these vocal patterns that now can be learned from machines and artificially recreated pixel by pixel. They know your mannerisms. They know your inflections. They know your speech patterns. They can take this and make you. How hard will it be in a few years to know what is real and what is not? Right now, the AI is so good in making deep fakes that defensive AI has no clue if it's real or if it's not. Now imagine millions of videos just being created, because it's AI. These things can be generated all the time. How many people are actually looking at these videos? Oh, it's not. But how much would it take to convince anybody that it's not real? I mean, right now, left or right, middle, right? We have a lot of information coming out where one group says it's true, the other group says it's not, but this is true, and then they say, no, it's not. And then you're here trying to figure out what is the difference. Cybersecurity is a huge field, and it's vast. There's 8 domains of cybersecurity that for like the CISSP certification that you're tested on. It ranges from everywhere from the business side down to the technical side. There is something out there for everybody. And place like SVU is already there. They already have the bedrock to offer a cybersecurity degree and a program. They teach discrete math. They definitely teach calculus 1 and 2. They teach calculus-based physics. By the way, Army Cyber Command, if you're interested, they look at physics. They're very interested in physics. The Navy, you can't commission in the Navy unless you have calculus 1 and 2. However, you don't need to take calculus 1 and 2 because there's business math, right? There's statistical analysis. There's data analysis. The three parts that make up cryptanalysis, and that is decrypting, that is linguistics. You have to know the language. You have to know the language that you're trying to decrypt from. There is math, of course, right? It's algorithms. But there's also data analysis. The English language, there's certain patterns of use for letters. And it's a nice little histogram, right? So the letter, I believe the letter E is used most, T is next most. So you use these data analysis of the language to look at an encrypted text to start deciphering the language. Is there any questions so far? Is there any answers? All right. Jeff?
Questions?
Yep. Now you said you have a few weeks. Are you guys kicking something off?
Yeah, so about 2 weeks ago, we did a computer science week where we had some people come in. We had our 2 remote professors come into campus, and then we're bringing you in, and we're trying to do this more often this semester for the computer science program.
Are you interested in starting a cyber club?
Yeah, definitely.
The Cyber Defense Lab at VMI would love to help you guys kick that off. Your ROTC cadets, we will teach them offensive and defensive cyber. Of course, they're going to have to sign a hacking or a ethical hacking statement. We don't want them coming back here and learning what they use or teaching others. But yes, so your ROTC cadets are already able to participate in what's going on. Currently, Army ROTC is going up against my cyber defense cyber captains in the NSA Codebreaker Challenge. Who knows about the NSA Codebreaker Challenge? All right, well, Google that and sign up. And here's why. If you complete that challenge, you will have a job offer from the NSA. And they usually start you in at a GS-12. A GS-12 is like 100,000 to about 170,000, depends on where you work. But it's also fun. Staff, faculty, and students can all compete. So my cyber captain, my cadet in charge, threw down the gauntlet. And he challenged the Army ROTC. If you think you can beat us, come and try. And as of yesterday, they picked up the gauntlet and they're just going for it. So now I have 2 different groups at VMI competing for the NSA Codebreaker Challenge. Tell your friends, it's free, but more importantly, you never know who's interested in solving puzzles, right? If you like solving puzzles, go out there. I just got off a tech talk with the NSA's chief code breaker last night, and he actually ran through how to start cracking code, and this was fantastic. You know, not very often do you have this. Now, this was open to only the senior military colleges, the service academies, and centers of academic excellence, but the code challenge is open for everybody, and it's a group effort. There are CTFs, capture the flag events, that occur all the time. And these are challenges. There's policy and risk management CTFs. How do you do policy? We ran a Decide, where we took cadets and we threw them in a real world environment. You're the CEO, you're the chief marketing officer, you're the CIO, you're human resources. You're also the guy that's in charge of the data. You've just been hacked. What do you do? It took about 2.5 hours for them to stop trying to solve the problem and start working the problem. They were like, well, we can fix this server. Well, we got to shut it down and repair it. No, your business is crashed. You have no income. You're not getting your people paid. And more importantly, your customers are cheesed off. You're losing money. You're gonna fold. And after about 2.5 hours, they started getting it. They're like, whoa. And it was really interesting. They just elevated. They started thinking like leaders, right? And they're like, well, we better tell somebody what's going on. Communicate with the outside world. Let them know we're helping them. More importantly, employees. I'll tell you what, it's pitchforks and torches. When employees don't get paid, they want to be paid. They have bills to pay. They either have a mortgage or they live, they're paying rent. They might have a car payment, might have insurance payment. They definitely like to eat, right? So they're not getting paid. So all of a sudden they had all this epiphany, a very large epiphany, that, hey, we need to do something. So there's CTFs for these type of platforms. There's capture the flag for open source intelligence. There's capture the flag for reverse engineering. There's capture the flag for cryptology. Anything you can imagine, there's a capture the flag event, and these events are free. And you just form teams. Usually it's just formed from students that, hey, we have a common interest. And if you do have a common interest, get together with some people and let Jeff know, because we want to know. Because we'll help you spin up your cyber club. Not only will we teach you the breadth of cybersecurity, but we can also help you form CTF teams. I personally am on a mission to get cyber games as an official NC2A sport. It should be elevated to that level. They did it with esports. Why can't they do it with cyber sports? First is that VMI, right? I've got to break that barrier. Cadets need a permit to go off post. If you're sports, you just give your professor the permit and you're gone. With CTF, we're not there yet, but we're getting close. VMI recently placed third in the SMC competition. It was senior military colleges. That is Texas A&M, 35,000 students. Virginia Tech, roughly 26,000 students. The Citadel, 5,500 students. I had no idea about this next university, but this is important. University of Northern Georgia, 21,000 students, but what's important about them? They have, 4 people in the top 40 that are competing for the first ever US cyber team. They're going to be competing in Greece. There's Norwich, which is about 3,500 people, and then there's tiny little VMI. 1,750. Now what's interesting about that is rats can't compete. Those are 4th year. You would know them as freshmen. They can't compete. We lose 500 plus of our student body. We took 3rd place. That's not bad. And it's from a decimated team. Last year, their CTF team, most of them graduated. And they didn't have a framework in place that you're continuously training anybody who's interested. And we also did the side platform, which was very interesting. So there's a lot of things out there, a lot of competitions, but more importantly, there's also free training. For, I believe, $35, SANS Institute, S-A-N-S, they offer CTF training, but if you do moderately well, they'll give you a $3,000 scholarship so you can take one of their certifications. Any one of their certifications on your resume, all of a sudden people are like, whoa, we need to talk to this person. We need to hire this person. But if you do better, they're going to give you an $18,000 scholarship. And they're going to say, hey, get a lot of our certificates. By the way, you want to come work for us. You get multiple SANS certificates, you're going to have a job. They're going to look at you and say, hey, that's fantastic. And what this does is it spins you up. It teaches you the CTF exercises. Trying to find out interests, right? Are you a STEM, non-STEM? As in science, technology, engineering, math?
My major, computer science.
Okay, STEM. If you're interested in STEM, they have that. They have non-STEM based CTFs. They have something for everybody. And even in competitions, you're going to break it down, right? you need digital forensics. Does anybody know what digital forensics are? Sort of? I recently, I actually took a graduate course last quarter. It was actually fascinating. There was, Jeff, who was that gal? Casey Anthony. Yes, Casey Anthony. The defense completely shut down the prosecution. And this is why. The prosecution was using digital forensics. They didn't really understand what they were doing. So they said, hey, we have all this data, this log stuff from this browser, but the underlying database, it's basically custom. It's proprietary. So they went back to the developer, and the developer changed the algorithm on how it pulled data out. Well, the problem was, based upon if you use the non-developer modified browser and database or the developer based, she either looked for ways to, unfortunately, kill a child one time, or 86 times. 86 times, it looks like she's really intent. One time, it could be anybody sitting on the computer. What they didn't do was they didn't validate their tools. They didn't know about tool validation, which means you bring up this browser and you go to Microsoft.com and you record what it records. And you get a baseline. And then you take that image of Casey Anthony's machine and you put it on a clean computer and you verify the results. You go out to Microsoft.com and you do the same thing. They didn't do that. There was another individual, what's his name? Bradley? Who's that guy in Star is Born? Bradley Cooper. Well, there's another Bradley Cooper. It's not him. Now, what was interesting about Bradley Cooper was a police detective who was not certified in digital forensics. He had no idea how mobile phones work. So he decided he was going to follow some steps, and he accidentally deleted data. So then he called up the help desk, and the help desk said, yeah, enter this code. And he actually reset the entire phone. He wiped the entire phone. Now, he was not certified. He didn't really know how to get into the phone, and he didn't know how to take what's called a static copy. It's a bit-by-bit copy of an operating system. So you keep an image, and then you encrypt it with a signature to know that, hey, this is true, right? Nobody messed with it. That's what a digital signature means. But it turns out he had to have done it 3 times on the same phone. Now, he didn't tell anybody that he did that. It came out in the trial. Bradley Cooper was convicted of a murder, and what was on that phone could have possibly got him off, proved his innocence. So digital forensics is huge. Every time you have a ransomware attack, they come in, they take a static copy. It's called static capture, but there's also live capture. So say like Alyssa decides she wants to start mining Bitcoin, right? And it's against the rules here. She just spins it up, right? And it's like, Jeff's like, ooh, wait a minute, I noticed some weird power consumptions here, some fluctuations, what's going on? So then he goes to Lunar and says, hey, we need to take a live capture. We need to see what's going on while Alyssa's on the system, while she's doing her Bitcoin mining thing, right? And so it's called live capture. You look inside the memory, right? You look inside the cache files, the page files, which is a swap file. So digital forensics is huge. So they have cryptography, digital forensics. They have reverse engineering software, reverse engineering. They have web exploit. Web exploit's huge. Not a lot of web development security going on out in the world. All right, I think that's all I have. Man, I forgot how warm it is in here. Yeah.
We turned the AC off because it made too much noise.
It's messing with the stream.
So, first of all, I just thank you.
Yeah, no problem.
Let's give